So I'm going to demonstrate association rules analysis. We'll be using the bank data set. I have already imported the bank, but I'll do it again just to demonstrate. So in the meantime, when I do that, if you're not following along, maybe it's worthwhile to get familiar with what the data set is. You know, what kinds of variables are in the data set, and I'll do a few exploration plots to better understand those variables. I think it's on 63, page 63. And you can start to relate your personal experiences with banks. Those typical common services that retail banks offers to consumers. So data source, bank, and you can see there are only 3 variables, and I'll explain later after I finish the demo to talk about the data formats. But there are a large number of rows, so it's a very long table. And of the 3 variables, one of the variable has to be an ID. You need an ID column here. One of the variable will be target, which is the actual choices. Account would be an ID. Service here, the service refer to banking services, including credit card, check-in, savings, certificate of deposits, and loans, and etc. And be sure to select target for services. This is a key. Visit, you can either retain or exclude it. This is relevant to the sequence analysis, which adds one more dimension to the analysis. When you consider time sequences, first visit versus second visit, then you can model with more details. Here we only consider bundles, so there's no time element here, but I can keep it in it, but reject the variable later on. So that is the correct setting. The service is a nominal variable. And one more key setting is that remember to change the row of the data set to transaction. And this is a transaction type of data set, where each row documents the customer who adopt the service and the exact service that is adopted, and possibly a time variable, which is the visit, right? On which visit did which customer adopted which service. So I have 2 banks. So I already did those, but start dragging the data source over. And what I first did is the graph analysis to take a look at the general distributions of the services. Think about this data set where you only have, let's say, only have 2 relevant columns. One column is customer ID. The second column is the service, banking service adopted. So, which customer has what service. And a customer can have multiple services. So the same customer can appear on different rows, on multiple rows, at least one. So you wonder, what is the service that is used by most customers? In a banking context, deposit, so savings account. We're talking about accounts. So think about the accounts that you have in a typical bank. Chase, Citi, Bank of America. You have checking typically, savings sometimes, credit cards, most definitely. So different credit cards are different accounts. They can be modeled differently. For here, I think the data set has one card per type, one account per type. So it doesn't model two types of checking accounts. It doesn't model two types of credit cards. So assuming everybody has only one credit card, if any. Right? And for this data set, Stats Explorer will not work because there's no input. And so that's why I use Graph Explorer. And after you run, when you say Graph Explorer, make sure you modify the sample amount and make sure it takes the entire sample. And where is it? Okay. Now, so the Graph Explorer made a pie chart. Even I'm thinking I need to make a pie chart, but it's already made. Great. So a pie chart is better than a bar chart because you can see relative comparisons very quickly. What's the most frequent adopted services? We can compare the chart to the data page.
I don't have a pie chart.
Oh, you don't have a pie? Oh, you do not?
No.
Do you have?
A bar graph.
Really? You can make one. So you know where to make, right?
It's a user graph. That's what you made it.
Really?
Yeah, user graph 1.
Did I not?
Left.
Did I not remember? I made it. Great, and it saved it. I thought it don't save, but go to plot and pie chart, and select service as a category, and you have your chart. So what's the number one service? Checking account. Almost as much. Savings account is almost as much as popular, but not quite yet. You know why. ATM is the ATM card. And let's look at some of the others. CD, certificate of deposit, earns more interest, but locks in and has penalty. Checking card that is used to replace the check balance sheets, I guess, when you present to the bank. Credit card, somewhere here. Credit card. And this is, do you know what this is?
Home loans, yes.
Sean, you familiar? Yeah. Yeah. Only homeowners. This is only relevant to homeowners. And auto is the auto loan. Yeah, you do have. It's a small piece of pie, but other, including all else. Can you think of one that's not on the chart?
Bonds.
Bonds, investment.
Like government savings bonds.
You do. It's managed by retail banks. May not be.
I just know
But,
I got some in the 90s from my great grandma, and so I haven't done anything.
Okay.
But I know they have bond services where you can cash out.
Yeah. Oh, bonds, government bonds. Yeah, I never bought it, so I don't know. What else? Mortgages is one of the popular types of products.
Refinance.
That's part of mortgage, I think. Yeah.
Car loans are a big one too.
Car loans, yeah. Do retail banks do as much car loans as mortgages? I think mortgages might be more prevailing on the surface because it's more profits, basically. Yeah. So that's that, and some of these will become relevant when we look at the results. Okay, so we're talking about these 10, 11 services. The question we ask is, what might be some of the popular bundles that customers choose together? And how is that information useful to me as a banker, as a, not banker, bank. What? Bank owner. I can, with that information, I can think about doing some targeted marketing to those who only have one of the services. And if I know the expected percentage of customers who already has a service, what's the likelihood of those customers also will be interested in B services, but just haven't had the knowledge about it, or didn't know that we offer it, or was just busy and hadn't got time to do anything yet. If we have an expected likelihood, and if it's high enough, then it probably justify a targeted marketing campaign. So that's the idea. So let's do some association rules analysis and see what the discoveries can it turn out. It's under Explore, the first one, and very interestingly, I'm talking about association rules, aka market basket analysis, but there is an association and there is a market basket. They differ by the type of data set that they use. Association rules uses the transaction type of data set. The other uses a market bundle type of data. You can convert between the data types, and I'll talk about it in the slides shortly. But they do come with different options. So association rules, and once you connect it, take a good look at these options. And I'm going to throw this and get a new one. So these will be the same setting as you have. Maximum items. This is the cap of the number of services in the bundle that you can model. And for now, let's change it to 1. What does that mean? We, for both antecedent and consequent, we're only looking at one service. We don't allow more than one service in any of those positions. So things become simpler, right? If customer chooses a service, what service does he also choose? And minimum confidence level. What is confidence? me talk a few about that. So a rule takes this format: if antecedent and consequent, if A then B. That means if you have knowledge that this customer or this transaction, this basket or this purchase, this order, whatever, contains a product or a service A, then what else tend to be in the same purchase order? So there's an order here. A and B cannot be switched, otherwise it changes the story, right? A rule support. Well, let me talk about confidence first. We have A and B. Rule confidence calculates or indicates the likelihood or the percentage of those who you know have purchased A. What's the likelihood of also purchasing B? For example, 10 customers purchased A, and that's the only 10 that you have. 10 customers purchased A, 5 of them also purchased B, and that's 50%. That's conditional likelihood of the rule. That's confidence. But then what's support? Support is a sort of a condition that qualifies whether a rule is at all valuable. It takes account of the entire number of customers. So let's say if your entire data set has 100 customers, and you know that 10 of them purchased A. Of these 10, 5 of them also purchased B. So the number of customers who purchased A and B would be 5. And the support is 5 out of 100. So what does it tell you? It tells you how relevant this rule is. If only one customer ever purchased these two products together, this rule might not be very interesting, because how in the world are you going to do a lot? You can't do much, because this rule doesn't lead to a combination that is highly represented. So it's not important, sort of. And that bundle may be coincidence. So there's no pattern to be acted on. So support is sort of like a condition, a precondition for how important the rule could be. And rule confidence tells you how important is it regarding product B. How important is it that you know customers also has A, right? Out of all the customers, the knowledge about customers getting A gets you closer to be able to sell product B, because it's a subset that also purchases both. So kind of keep in mind the differences between these two concepts. Typically, confidence is more than support, and that's typically, and you can think about why. It's not of a, I don't go much into detail, but that's a typical case. Okay, so coming back to the demo, here you have a confidence level. You can set a threshold, and you have a support threshold. And confidence default threshold is higher than support threshold, because that is typically the case. Confidence is a conditional probability, tend to be larger than the overall, probably and the support is a sort of it's a combinatorial percentage. It's much shorter. It has more constraints. But anyway, these two settings help you filter out those rules that are less important on 2 dimensions. Confidence level help retain only those rules that reach a certain level of confidence. Remember, confidence is the percentage of customers who already purchased A also purchased B. The focus is on B. The information is about A. This is also important. You need it to be high enough. Instead of keep it at 10, I want to retain all the rules that has at least 25% confidence. That means at least 1/4 of the group who already purchased A also purchased B. Other than that, I don't care, because it's less confidence. Support, I want it to be higher, but not too much higher. Definitely not over confidence. So I'm going to increase by twice to 10% of any rule that surfaces. I want those rules with the support of at least 10%. What does it mean? Any rule that I see must have customers who buy A and B more than 10% of the chances. So at least 10% of the entire population of the entire data set has to purchase both products for me to pay attention. So this drastically lowers the number of rules that it discovered. Extreme cases, you keep those as 0, and then you have the entire rule space. And so we changed 3 things, and that changed a lot of the results. And one last thing to check, which is according to the tutorial, modify this export rule by ID to yes, so that when you export the data set, you have the rule number as well. Okay, now you can run. So, a question for you before you look at the results. Think about support. Of all the possibilities, in this case, it's banking services, and most of the services. Think about 2 services that are the most frequently used by the same person. What are they? Checking and saving. So the sort of the hypothesis or the guess would be this rule will have the highest support. Is that support, right? It's not confidence, it's support. Okay. Of this rule, it's either if checking then saving, or if saving then checking. The order matters. So pick one for now. Let's say if checking then saving. What do you think the confidence will be?
If there is checking, then there will be saving.
Near 100, near perfect. That's one guess. Can you say that again?
I was just saying about the condition. If there will be like checking, then there will be saving.
So what would be the confidence? 100%. So the case about 100%, it's rare, but I'm not saying this is not possible here. The case of 100% almost makes it a dependent condition. Sort of like if let's see, if you have a checking account, wait, hold on. If you have a checking account, it's 100% that you have a saving account. That means before you can open the checking, you must have a saving. That's kind of a dependency rule, right? And in banking services, there are such rules. You know, you want to get a credit card, I'm sorry, you need a checking account. You know, so the rule of credit card, if credit card, then checking. You can if that is a rule, then you can know, you can not guess, you can know for sure. The confidence is 100% because B depends on A. Oh no, A depends on B. A depends on B. You need to first get B, then you can have A. So the rule, which says if A then B, is not very useful. We'll see it. So let's see if the results conform to the expectation. Your highest support might be checking and saving, and let's see. So this is how you look at the results here. A bunch of graphs, and these graphs they help you navigate and start to shift your attention on those rules that deserve attention. In the case that you have 500 rules, and it's a lot of rules. Here, quite a lot. Hold on. This is not what I intended. Support type. Today, maybe I need something higher. Still fairly a lot. I want the numbers to be higher because I want to simplify the results so that it's more clear. My target is 12 rules, so I'm increasing the thresholds. Okay, let's see. Okay. Let's see. Now, so this blue line, is support. It's a lower left graph. This blue line is support. The highest support is at here. %. What does it mean? So 54% of the customers have two services as described by Rule 1. We'll take a look at Rule 1. What does it say? But the highest support here is 54. Slightly more than half of the sample size. The prediction was checking and savings, right? You can take a look at description of the rules by going to rule description. You can keep it on the side. So I see how the chain of rule can be as high as 3, and that is not what I intended. So I need to update this characteristic. But even sequence, oh yeah, there's a need to disable the sequence variable, which I forgot to do. So that's what made it happen. On the data, on the variable property of the association node, go ahead and disable the visit, which is a sequence variable.
Why we are disabling the?
Yeah, with the visit variable, it automatically does a sequence analysis. So, and it adds more complexity to the problem. So it increases the, with the sequence, there's a time order. So then you can model first and second part of the rule. And that makes things complicated. And sequence analysis is, one more level of complexity here. So if you do that, and I remember my number was 10, so I'm going to change it back to 10. So this is 16 rules, almost similar, and this is a manageable size. This chart, stats line plot, plots the 4 stats, the 4 quantities for every rule by indexed by the rule ID. So the x-axis is the rule index. You have beginning from 1 to 16 rules. So when you click the exact aligned position, it won't work in the middle because there's no rule over there. So if you click the right point, it will highlight where the dots are, and when you hover, you can see the statistic. So remember the highest support that we anticipated, and it's by looking at this line. This line is something like this one. This line. Wait, no, hold on. Support is this line, the 3rd highest line. And of all of these rules, the highest support is over here. It's a peak. So, and there are 2 rules that share the same highest support, which is expected because when you switch order, the rule changes, but the support don't change, right? So what are these? Did you see the description?
Yeah.
Checking and saving?
Checking and saving and checking.
Yeah. So you can change the order and change the rule, but don't change the support. Great. So that's rule 13 and 14, which is the case. Great. When I took a guess, I think I was smiling. I've got a rule that has 100% support, but didn't work that way. I thought, checking account and checking a check card would be 100%, but didn't work out. Anyway, so that's the highest support, but highest confidence, I think checking and saving. If checking and saving might be the highest, is that the hypothesis? If checking and then saving. Let's look at the confidence. Confidence here. We have 100%. Confidence is staying on the top line. And the very first two rows have the highest confidence. So what does 100% confidence mean? If A, then 100% B. Then B should be the condition of A. Right? It goes backward. Right? B should be the condition of A. If you know, well, let's see. If the person already gets B, it's guaranteed this person has A. And typically it's the dependency of the services of banking on the checking account. You have to have a checking account, otherwise, sorry, because we don't have your credit. We don't know you, right? Getting checking account approved and having a checking account, being able to monitor the balance, gives banks a lot of confidence in, in approving some credit. And when you look at the first two rows, that's it. Home equity line of credit depends on checking. If you know this person has home equity line of credit, you almost guarantee that this person has a checking account with this bank, because checking account is a condition for the other additional services. The second one, checking card, this is almost like a no-brainer case. If so, based on the first one, that's fine. The second rule number 2 has perfect confidence. What does that mean? If you know the customer has A service, you can guarantee the customer will have B service. Then can we go after all the customers who have A service to promote service B? But they already have it.
Oh, no.
Right? So this is the rule with the highest confidence. But you can't do anything. You don't need to do anything here, because these are the rules. Right?
Would it be the same thing
Not.
as dependent? What you mentioned
Oh.
earlier?
So the dependent cases are a exception, I think.
Okay.
So in case of dependencies, whatever rule that you discover might not be useful, because that's a dependence. So don't mistake a high confidence rule to be a useful rule, because it might be a dependency. Right? But the analysis doesn't take into account the dependencies. This is an exploration tool, right? So it requires you domain knowledge to interpret the results. If you switch them around, let's see. If you have checking account, what is the confidence that you have about them also have home equity line of credit? It doesn't show up here. So it probably has pretty low support. Support will be the same, but support will be above 10% because it's the same. But confidence might be low. Under what condition, if you add one more service, then you can be fairly confident that the confidence of home equity line of service will increase. What one additional service do you need to be part of A? So if you know a customer has a checking account, that alone doesn't give you enough confidence about home equity line of service. But what else? If you can add one more, of all the services that we have, ATM card, credit card, what is, who needs a home equity line of service? Most
How-
likely.
home loan?
Has to be a homeowner.
So mortgage?
Yeah,
Oh.
why not? But mortgage is not here. So hypothetically, you can model that and you can make a prediction, and you can confirm it by using the method, the mining. Yeah. What is the let's see. Let's look at a second highest confidence case. So in this is the rule number 3 might be the second highest, and rule number 3 says if you have credit card, you have high confidence that this person also has checking account. And I almost thought that should be 100, because having a credit card depends on that you have a checking account, but it has changed probably. So in the case of checking, let's see. And expected. And there's one more statistic here. I talk about support and confidence. There's an expected confidence. Expected confidence gives you a comparison point. Expected confidence is simply overall of all your sample, of everybody, what is the likelihood that this person has B? You know, overall, what's the likelihood of this person has B? What do you think about checking account? What is the percentage that of customers that have checking account without knowing anything else? Pretty high, should be pretty high, because checking account is a basis of a lot of other services. So you can almost say that the first service, the very first service, the majority of the customers deal with the bank would be the checking account. Otherwise, they wouldn't even enter the system. You know, if they are denied with for a checking account, you know, they're not going to get anything else, typically.
Checking.
But savings is another case.
Checking account can be like opened, but not used.
That's
Many
right.
people have
Yeah,
credit
yeah,
cards.
right. There's no usage data here. It's
So you
only
have to take that into
status.
consideration.
You know, that will, that will make it a more powerful model and give it more information. I think that falls into the quantity side. You know, as if you not only know that the customer buy soda, buy Pepsi, but you know this person buy 10 dozens of soda. You know, in this condition, you can, find out pretty interesting rules. So let's look at the expected confidence. You know, these lines, number 1, 2, 3, 4, number 14, 15, 16, they are at the same height. And this line is expected confidence. And given that they are on the same height with the same percentage, over 85%, they are all talking about the same consequent service, which is the most popular service of this bank. You know, and it's definitely checking account. And and you verify that, you see that the B service of these rules are checking. So you confirm that with the data, and you confirm the meaning of the rules. So what might be interesting here? All the dependencies are not interesting because that's a rule. So what might be interesting here. I think Rule 7 is pretty interesting. Well, yeah. Maybe. Depends on how the ATM card is used. ATM cards are typically joined from the checking account. So having an ATM card typically means there's a checking account. So cross-check with the checking to saving. Yeah, checking to saving. Rule 7 and Rule 13. Rule 7, Rule 13. They're on a similar height. That gives you a confidence of 66.8%. So if you know a person has a checking account, there's close to 66% that a customer also likely to have or open a savings account. A savings account, a savings account is something that the retail banks will value more than checking account, because savings account has less fluctuations, gives banks more certainty in predicting the volatility of the account, so that they can better invest those asset. If part of the priority of the bank is to promote savings account, then these two rules might be useful. So that concludes the demonstration. On homework, most critical is that you follow the specifications. Make sure those importing processes and properties are right, and a few key settings there that you need to change, and then you need to know how to get the rules, how to extract the rules, and you have sorting option there. So you're asked to report the rule that has the highest number on some statistic. So you will sort those rules and report the statistics. Any questions? Great. So let's take a break. We'll come back at 7:40. Let me continue the recording here. So I earlier I restricted the rules. I can only have one. Now let's expand it to 2. And lower, when you have a bigger bundle, but if you don't increase the threshold, it don't change much, and so you need to reduce some of the thresholds. So I can keep 10, but confidence reduced to 20. And let's see what new roles can be discovered. Well, it didn't change much, didn't it? So I used to have 16. Now there are 17. So one more. So I need to reduce even further. Now, there has been some change. We have almost 50, 51, 51 rules. And this set of rules, or the 16 rules earlier, is a subset of all the rules here, right? So it should include what we have seen. So there are some perfect, perfect confidence here, which is the dependency cases. The only difference is that their rule ID changed. Let's see. If you take a look at the rules, you can observe how many bundle rules are instead of the single item rule. Let's see. Well, not many. Yeah, not really a lot more. Maybe still because of the threshold I set. For restricted thresholds, the bundles just don't show up because it's harder to observe significant bundle patterns than single rules. So the additional ones that show up here is because I reduced the threshold for confidence and support. Let's see. Yeah. Okay, let's try one more time. And increase more flexibility. Now we have more diversities here. Instead of looking at randomly, let's pick some of the high confidence rules and cross compare. Rule 52. Let's take this example. Rule 52 has a confidence of 100. This must be a dependence case. Let's see if it's a bundle. It's not a bundle. It's the same one. Right. Instead of looking at the perfect confidence, maybe let's consider something lower. Rule 43 is a bundle. That's great. So rule 43. If savings account and checkings account, then auto loan has a confidence of 64%, which means of those customers who have at least checkings and savings account, there's 1/3 of them close to that also will have an auto loan. Now that makes sense. If a household has both a checking and savings account, it's a household that is more established than the otherwise, right? For a household that has a savings account, that means there's a need for saving at least. Now, there may be a need for the saving for future use, you know, a college savings account maybe, and what do you think? Savings and check-ins. Instead of only having a checking account, have both savings and checking account. Maybe we can compare another rule, see if we can find it. If checking, then auto. Do you see it? You can sort by initial letter of the. If checking and auto, it doesn't show up. It doesn't show up. Yeah. So based on the surface rules, what I can reason is that it's better to know that a customer has both checking and saving, and then to predict the likelihood of an auto loan than if I only know that the customer has checking account, but not necessarily savings account. So knowing both information about both the checking and savings account tend to increase the likelihood that this customer either has auto loan or will be interested in auto loan. So it gives you a potential a marketing strategy. So how, if you were asked to sort the rules by confidence or sort the rules by support, how will you do that? So you need to extract a table with the rules and their statistics to be able to do that. You have the rules table, report, which is like a table actually, and it does have all the statistics that you want for every rule that qualifies based on the thresholds. So based on this table, you can sort by lift, inverse, or you can sort by support. The highest rule that has the highest support rule will be checking and saving, which is obvious here. And the two rules have the same support because they are the same combination. Only the order is changed. But when you switch the orders, their confidence changed dramatically from 60% to 80%. Yeah, most likely it's because saving is not the same as checking. Checking is more popular, right? All right, that's it. That's all I wanted to demonstrate. Any questions? I think you're good to go. Right, so I'm gonna finish.